everyone. Today we're going to look at lesson 2.1, basic functions and their graphs. So we're going to begin with a relation. And a relation is a set of ordered pairs. The first component of the ordered pairs is called the domain of the relation, and the set of the second components is called the range of the relation. In the first example, we're going to find the domain and the range of the relation. And we have 0, 9.1, 10, 6.7, 20, 10.7, 30, 13.2. Now, the domain is the set of all the first components. And since we're dealing with ordered pairs, the first components of an ordered pair represents the x values. So if I wanted to find the domain of this relation, I will look at each value that is first in the ordered pair, and we have 0, 10, 20, 30. The range represents the second component of the relation, and we also call the second components in the ordered pair the y values. So whenever we look for the range, we're looking for the y values or the second components, and they are 9.1, 6.7, 10.7, 13.2. If you ever see a number repeat, we only write it once. So remember, the domain is the first components of the relation, and the range are the second components of the relation. Now, since we're talking about relations, we're going to look at what a function is. And a function is the correspondence from the first set, the domain, to the second set, the range, such that each element in the domain corresponds to exactly one element in the range. So notice what I said with the relation. The first component is called the domain. The second component is called the range. And the domain represents our x value, or input, and our y represents our range or output. Now, whenever we're looking at a function, think of a car. We place gas in input, so that's the domain, the gas, and the gas makes the car output by running. So when we put gas in a car, the function is not to turn on the windshield wipers. The function is not to turn on the lights. The function is to make the car run. So whenever we input something, we should get one unique output. So that means that the domain cannot repeat. If the domain repeats, it's not a function. Now, let's take a look at some problems. And we want to determine whether the relation is a function. Now, whenever we're looking at a relation to determine if it's a function, we are looking at the first components. And if we look at the first components, the domain would be 1, 2, 3, and 4. Now, since none of these numbers repeat and each one has a unique output, then yes, we have a function. But if we look at B, notice that we have 6, 6, 8, and 9, and our domain is 6, 8, 9. Remember, if it repeats, we only write it once. Now, 6 goes to both 1 and 2. Can't have that because the domain needs to output one unique. Unique means 1. The domain corresponds to more than one element in the range, so this would not be a function. So whenever the domain repeats, it's not a function. Now, whenever we're looking at a graph, we can do something called the vertical line test. And the vertical line that intersects a graph in more than one point, the graph does not define y as a function of x. So in these examples below, we are going to use the vertical line test to identify which graphs are functions. All right? So, if we look at the first graph, and we could draw a vertical line anywhere in the graph. When I draw a vertical line, notice it hits at 2 points. Since it hits at 2 points, we would say no or non-function. Notice that it goes through the x-axis, so that means that that x value repeated. I didn't get a unique output, and so this is a non-function. Now if I look at the second graph, notice it only hits in one spot. So since it hits only one spot, it is a function. The third graph, when we draw a vertical line, it hits once, so that means that it is a function. And the last graph, when we draw a vertical line, notice it hits twice, so that means that this is a non-function. So if it hits once, a function. If it hits more than once, it's a non-function. This is very important. Now we're getting a function notation. And with function notation, f of x is equal to y. So sometimes you may see xy as your ordered pair, or you may see x f of x. F of x is y is f of x. So if you see either one, know that f of x means y means f of x. It's just another way to write y. Now we're going to evaluate a function. So we have if f of x equals x squared plus 3x plus 5, evaluate each. Now if we look at A, notice what left. What left is an x. I replaced this x with a 2 on the left side. So on the right side, I need to replace my x's with the number 2. Now, if we look at the right side, I have an x. Can't write x there. It's no longer x, it's a 2. So I'm going to write 2 squared plus 3 times, where's an x? But we rewrite it, making it a 2 plus 5. And then we solve using the orders of operation, and we get 4 plus 6 plus 5. And 4 plus 6 plus 5 is 15. So f of 2 equals 15. In B, we have f of negative x. So this time we don't have an x, we have a negative x. So on the right side, I need to change all my x's to negative x's. And we get negative x squared plus 3 times negative x plus 5. And negative x squared is just negative x times negative x, which is positive x squared. 3 times negative x becomes minus 3x. And then bring down our plus 5. And our answer is x squared minus 3x plus 5. Now, if we take a look at C, we have f of x plus 3. So now our x is changed to x plus 3's. So the moral is whatever is in the parentheses on the left side, make sure that that changes every x on the right side. And we have an x squared here. So it's not an x anymore. It's an x plus 3. Then squared plus 3 times x plus 3 plus 5. Now remember, x plus 3 squared is x plus 3 times x plus 3 plus 3 times x plus 3 plus 5. And using the orders of operation, we multiply first. And you could use the FOIL method or the box method for this, whichever way you were taught. And we have x squared plus 6x plus 9. Distribute plus 3x plus 9, and bring down our plus 5. Now we combine like terms with the highest exponent going in descending order. So x squared, we see no more, so let's bring that down. And then we want to look at what looks alike. And we have 6x plus 3x, which is 9x. And then we have 9 plus 9, which is 18, plus 5, which is 23. So our answer is x squared plus 9x plus 23. Now, before we end this, we are going to look at identifying the domain and range of a function from its graph. Now, when you look for a domain of a function, you're looking at what's happening along the x-axis. So act like you're taking a tape measure out and you're measuring from left to right to find a function's domain. So if I took a tape measure out and I started from the left, on the left of it, it's domain, so it's the x-axis. And I'm gonna highlight until I see it stop. And notice that the width goes from -2 to +1. Now, whenever you start your domain, we always start like this. Now, on the left side, we have starts at -2. And since it's a closed circle, we place a line. Then if we go to the right side, it stops at 1. And since the circle is closed, it needs a line. So the domain is -2 is less than or equal to x, which is less than or equal to 1. Now the range is how long the graph is. Okay. So if I want to find the range, I look from the bottom to the top. And we have, this is the lowest point. Act like it's a tape measure, and we want to measure the length. So the graph starts here on the y-axis, and it goes all the way up to here. Okay? Now, since it's the range, and we're on the y-axis, we begin the range like this. Now we have a closed circle, and that starts at 0. Since it's closed, we get a line. And it goes up to 3. And 3 has a closed circle, so 3 also gets a line. So our range would be 0 is less than or equal to y, which is less than or equal to 3. Now if we take a look at B, and we're looking at the domain, remember from left to right, this graph starts at -3, and when I measure it out, it stops at +2. And since it's domain, we place an X. Now, if we start with the number far left, notice this is -3. A -3 circle is open, so we need no line. But when it stops at 2. And 2 is closed circle, so 2 needs a line. And so our domain is from -3, which is less than X, which is less than or equal to 2. Now we want to find the height. How long is this graph? And notice it starts at 1, and the highest it goes is 2. And since it's the range, we have y. We start from the bottom. It starts at 1. 1 has an open circle, so no line. But it stops at 2. And 2 is a closed circle, so we need a line. All right. Oops, I'm sorry. Now, let's take a look at C. In C, we're going to find the domain and the range. Domain starts off like this. Range starts off like this. Left to right for the domain, it starts at -2 and ends at +2. So notice -2 has a closed circle. So -2 gets a line. But when we stop at 2, 2 is open. So we leave it, and we have -2 is less than or equal to X, which is less than 2. Now the domain, bottom to top. The lowest point on this graph is here, which starts at 1, and the highest point ends at 4. Now, it doesn't have a circle there, but if a line goes through, that means it's closed. Unless you see an open circle, it's closed. And at 4, because since it goes and touches 1, that's why we include 1. We go up to 4, the circle is open, and so 4 also gets a line. And our range is 1, which is less than or equal to y, less than or equal to 4. And last but not least, the domain and range. If we look at the domain keeps shooting to the left. And when we stop, it stops here. So if we read that from left to right, our domain will be from -infinity to 4. We're going to have a bracket. And our range from bottom to top. The lowest point is here at 0. And then that arrow just keeps going up because it's going to shoot up and just keep going up and shoot away. And it goes higher and higher and higher. So it's going towards positive infinity. So the lowest point, notice that it's closed, is at 0, and the highest point goes to positive infinity.